Greetings, calculus fans. All right, so today we're going to do more parametrics. All right, yesterday what we did is we went from a parametric to a rectangular equation, okay, or a Cartesian equation. Now what we're going to do is we're going to go from rectangular, which in our case it's going to either be coordinates or equations, but we're going to go from rectangular to parametric. All right, and actually this is called parameterize. Okay, it's kind of a fancy schmancy word. I know I used parameterization before, which is even longer, so definitely a way to impress your friends. All right, so let's start out with an example here. I'm going to clear this out, and the example is going to say parameterize a line segment with endpoints 5, 3 and -2, 1. Okay, so what I'm going to do is, of course, this is all in terms of x and y, and with a parametric equation you have x, y, and t. So I am just going to set that equal to my initial point, t is equal to 0, and this guy, my terminal point, equal to 1. So really what I need two equations, x equals and a y equals. Okay, so the new coordinates are t comma x and t comma y. Okay, so that's what I need to have here. I need to get those new coordinates. But really, this is what I'm looking for. I need two equations. That is the main thing. Okay, so some of you may ask, now, why is t first? Why isn't x first and y first? How do you know that? Well, this is the deal, math fans. T is our input. Just like when you have an x-y coordinate, you always solve for y, and x is your input into the y equals in slope-intercept form. Okay, so let's start out here. If I do x first, because I need two equations, so I'm going to do kind of two sides of the screen here. X is 0, 5. So this is again our t comma x, and 1 comma -2. Again, this is our t comma x. Okay, and so those are my two equations, or 2 points. What I want to do is I need to come up with an equation. Well, that's pretty easy, right? If I want to come up with an equation in terms of x and t, it's just like doing point slope form. So it's really easy. It's find the equation. M equals, remember, just make sure you're careful with it, 5 minus -2 over 0 minus 1. So my slope comes out to be -7. Point slope form is going to be x minus 5. I'm going to use the first point. X minus 5 equals -7 times t minus 0. So x comes out to be -7t plus 5. Okay, that's not so bad, right? It's pretty mellow. And let's do one for our y value. Again, we're going to put it in a coordinate. It's going to be 0, 3 for our t comma y, and the other point is going to be 1, 1 for our t comma y. All right, doing the same thing, we're going to find the equation, and we're going to say m is equal to 3 minus 1 over 0 minus 1. So my slope is -2. Put it in point slope form. I have y minus 3 equals -2 times t minus 0. And I distribute. I don't really need to distribute that, but I just move that 3 over, and I get y equals -2t plus 3. Okay, so that is your other equation. Now, that's actually your answer. There's only one other thing. Do you guys remember when we did all these problems, I always asked you for an equation, and you always had to tell me what is t between. All right? Well, what is t between? I already set this, right? On top here, t is between 0 and 1. So if I have to actually write my total answer here to get full credit, I would say x equals negative 7t plus 5. Y is equal to negative 2t plus 3. And t is between 0 and 1. And that's it, math fans. That's the answer. Okay, now it's really easy to check this just to make sure you got the right answer, to make sure you're going to get those exact same coordinates that we did before. So what I'm going to do is, how about if I plug in t is equal to 0? So this is to check. If I plug in t is equal to 0 into both this x and this y, I get negative 7 times 0 is 0. I'm plugging into this equation right here, the x equation. So 0 plus 5 is 5. So I get 5, comma. I plug a 0 into here. I get 0 plus 3 is 3. And I go 5, 3. Sweet. It's the same. Okay? And if I plug the other one in, so t is equal to 1. Negative 7 plus 5 is negative 2. And negative 2 plus 3 is 1. All right? And sure enough, there's that, and there's that. So that's just a good check to make sure you get the right answer. All right. Now, real quickly, math fans, while we're on the same problem here, what happens if I said I want to find ray 5 comma negative 3 to negative 2 comma 1. So instead of line segment, I said ray. So do you guys agree if I'm saying from here, so this is my initial point, and this is actually giving me direction, right? So it really doesn't have an ending point, doesn't have a terminal point. So, well, before it was t equals 0 and t equals 1, now it's just t equals 0. But don't you guys agree that it's now going, instead of, it's going to be this exact same answer, except it's instead going to say t is greater than or equal to 0. Okay, because it has a direction, or has a starting point, and then it goes towards negative 2, 1, but it keeps going. So that's what the difference between a line segment with has 2 endpoints and array, which just keeps going. All right, that's not too bad. I want to show you guys another way to do it, and this is actually going to kind of fit right nicely, very nicely in with our graphing calculator. Okay, so this is another way to parameterize. 5, 3, and negative 2, 1. So it's actually it's going to give you a different type of answer, but it's really the same answer mathematically. All right, so this is what you're going to do here, math fans. Is you're going to find the rectangular form first. So what I'm going to do is I'm going to find out the slope of this line. So m is equal to 1 minus 3 over negative 2 minus 5. That gives me negative 2 over negative 7, which is positive 2/7. Okay, so that's my slope. And then let's just use point slope. I'm going to use the first point. Y minus 3 equals 2/7 times x minus 5. And I get distribute that y minus 7 or y minus 3 equals 2/7 x minus 10/7, and then move add the 3 to both sides, so y is equal to 2/7 x plus 11/7. All right, so that is our equation in rectangular form in terms of y and x. But now this is where it's kind of cool. I want to convert now, so watch this. What I'm going to do is I'm just going to say, hey, you know what? I'm just going to make t the same as x. So I'm going to say x equals t, and then I can say y equals 2/7 t plus 11/7. Right? Isn't that the same thing? Okay. Again, I have another variable. I'm just saying x is t. This is kind of what we did a little bit yesterday with plugging in, doing substitution, right? So this is definitely a valid equation, a valid parametric equation. But now, of course, t is not between 0 and 1. What is t between? Well, if x is t, let's go to where x is. X is between 5 and negative 2. So that's what it is. T is between 5 and negative 2. Obviously, you got to put in the right order. Negative 2 and 5. That's it, math fans. That is another parametric. Okay, and then I can check it really easy. So to check it, I can just plug that value of t into the equation I created. Well, of course, since x is equal to t, let's just start out with negative 2. Well, I plug it in. That's negative 2. That works out well for x. And if I put 2 sevenths times negative 2 is negative 4 sevenths plus 11 sevenths is 1. Okay, and that's that one. And I can put a 5 in there. Well, 5 is easy. Put a 5 in there for t, I get 5 for x. And then 2 sevenths times 5 is 10 sevenths. Plus 11 sevenths is 21 sevenths, which is 3. And that's that one. Okay, so that is actually a really nice parametric. Okay, so now let's look at the ray part. This is what we did last time. So the ray, it started at 5, 3, and the direction was negative 2, 1. All right, so everything is going to be the same. We're going to come up with the exact same equation. Everything is going to be, we're still going to have x equals t, and we're going to still have y. We're going to come up with the same equation with the same slope. So it's 2 sevenths t plus 11 over 7. So it's and this is, of course, for our ray. All right. Now with the segment, it was between, negative 2 and 5. But now think about what's going to happen. Right? It's going to start at 5, and it's going to go more negative, right? You guys agree with that? This is since that's our starting point. So it's starting at 5, so that means it's going to be t is less than or equal to 5. That's all it is. It's not a big deal. Okay, but be careful which way you're going, right? We're going from 5 to negative 2, so we're going down. If I switched around and I went from negative 2 to 5, then it would be t is greater than or equal to negative 2. Not a big deal. But that's the only difference between the two is just your inequality of values for t. All right, that is not too bad. Let's try a couple more examples here. All right, so the next one is find a parameterization Okay, find a parameterization for the part of the graph that lies in quadrant 1. And here's your equation. Y is equal to x squared plus 2x plus 2. All right, so it's a little tricky because you've got this part right here. That's just going to basically change our value of t, where our t is. Now, I think it's kind of a good idea to understand what the graph looks like because you know where it's going to be in quadrant 1. All right, so first of all, I know my vertex is opposite of b over 2a, so opposite of b over 2 times 1. So it's negative 1. So it's negative 1. If I plug a negative 1 in there, I get negative 1 squared is 1. 1 minus 2 is negative 1. Plus 2 is 1. So my vertex is 1, 1, or negative 1, 1. So I'm really at negative 1, 1. I'm really here. And you guys agree that my graph is going to look something like this. So now let's go back to this. Where is it in quadrant 1? Do you guys agree it's in quadrant 1 where x is greater than 0? Okay? And it is, because right at this point right here, that's where it's going to start to be in quadrant 1 where x is positive. That's not always the case. That's why you need to actually sketch a picture, because what happens if it looked like the graph looked like this? Right? That wouldn't be true. You'd actually have to look to see at this point here kind of where x is positive or whatever, but also y is equal to 0. Okay, then it starts to get into the first quadrant. But for this case, that's good. It is truly where x is greater than 0. And let's make our parametric equation. Okay, again, this is going to be I'm going to even write this on here. This is easy when it's this case, because I'm just going to say, well, first of all, x equals t, and then y equals t squared plus 2t plus 2. And right, this is a big thing here. X is greater than 0, so that means t has got to be greater than 0. Not greater than equal to, because it's got to be in quadrant 1. All right, and that's it. That's your answer for that problem. That's pretty easy to parameterize that, right? Okay, so let's do a couple more examples here. This is not that bad at all. And this is just a little more practice for finding values of t. So let's do this guy here. Y equals x squared plus 6x plus 1. And I want to do the right side. That almost makes it easier, as opposed to giving you a quadrant, telling you quadrant. Right side, what does that mean? Okay, well, I can't just say x is greater than 0, right? The right side means I've got to figure out the vertex, and then x has got to be greater than that x value of the vertex. So let's find the vertex. Opposite of b over 2 times a, which is negative 3. Okay, I don't even have to find the y value, do I? All right, so I just know that my equation is going to be, and I guess I could write out the whole equation. It's going to be y equals t squared plus 6t plus 1, x equals t. But I'm really kind of just practicing finding values of t. And so do you guys agree this is going to be t is greater than negative 3? That's the right side of this parabola. Okay, how about this one? So again, this is just to find the values of t. So y is equal to x squared minus 4x plus 3. And I want to do quadrant 2. Okay, so again, you got to figure out where the vertex is. You got to see where this graph is. So we're going to do opposite of b. So opposite of b over 2 times 1, which is 2. So it's 2 comma, and if I put in 2 in here, I get 2 squared is 4. 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. So this graph is going to be at 2, negative 1, and it's going to go up like this. And now what you're doing is you're kind of saying, I need to really check that point out, because I'm saying it's got to be in quadrant 2. Where is it going to be in quadrant 2? So let's actually pick a value. Let's make x equal to 0. Well, if x is 0, you get 0 comma 3. Right? So a better graph of this, and that's why it's good to make a good graph here. So you have 2, negative 1, and it's going to be 0 comma 3. So it's right here. So I know my graph is going to look like kind of like this. That's a really sad looking parabola. Okay, but I truly know that when it's in quadrant 2, this is where x is less than 0. So that means for this problem, it's going to be t is less than 0. Okay, so let's do one more example here. And this one's, it's a little tricky just because you need to know where quadrants are and everything. What if I said y is equal to x squared plus 2x minus 3? Again, if you parameterize it, it's easy. You put the t in there, set x equal to t, you're good to go. All right, but I want to say it's in quadrant 1. So that's not quite as easy, and the only reason I say that, math fans, is because if I graph this, let's find the vertex first. So opposite of b over 2 times a, so 2, so the vertex is negative 1, and if you plug it in, you get negative 1 squared is 1, minus 2 is negative 1, minus 3 is negative 4. So we're at negative 1, negative 4. And roughly my sketch looks like this. So as you can see, if I want to be in quadrant 1, I'm over here. So I can't just say x is greater than 0, because that would include this guy right here, and that's not correct. Okay, so really what am I looking for? I'm looking for where y is going to be equal to 0. That's where it makes the transition. I'm still looking for x values, because it's still, if I parameterize it, it's still y equals t squared plus 2t minus 3 and x equals t. That's all the same. Okay, it's just, hey, now what is the value of what's the value of t? Well, that's pretty easy because I have to see where y equals 0. So x squared plus 2x minus 3 equals 0. And this one actually factors nicely. So you get x and x, I get plus 3 and minus 1. Okay, so I get x equals negative 3 and x equals 1. So this point here, well, I know this one is my negative 3, so this is the one I'm concerned about, where x equals 1. That's where it crosses that into the first quadrant, so that's what my answer is. Okay, it's going to be t is greater than 1. All right, that's it's a little tricky, but you can't just assume right away that if you're in quadrant 1, x is positive, because it doesn't always make sense. If I say left side and right side, that's actually really easy. Okay, but having, in a quadrant, you got to do a little investigation. All right, so that's it, math fans. It's not too bad. Showed you 2 ways to do that, and tomorrow what we're going to do is we're going to actually do a little bit more with our graphing calculator. All right, that's it. Have a great day, math fans. Goodbye.